Thank you all for joining here. Today our talk will be about electric trucks and some affiliations regarding that interesting topics. Let me first quickly introduce you Transport and Mobility Leuven for those that really don't know what we are exactly doing. So we are an independent research company. We exist now for 21, 22 years approximately. We are a spin-off company from the University of Leuven, who is currently still a majority shareholder. Then what are we doing actually? Basically, you can just summarize it under the umbrella of impact assessment. So in the end, whatever our studies try to aim for is to figure out what is going to be the impact of a certain transport policy measure and how exactly is the impact going to be, let's say, in a quantitative way. And then you can ask, okay, and what exactly are you then researching? Well, apparently we are researching everything in the world. So mobility nowadays takes on everything. Everyone has an opinion about this. But that is because mobility is very pervasive in our lives. And for that, we just do not only focus on road transport, but we also look at what happens in, for example, in air aviation sector or in the freight sector or rail, the passenger sector. We look at public transport, you name it, we study it. And given that we are about 30, 35 people now, that means that we have a couple of hundred projects running in parallel, which gives you also an idea of the breadth of our company and the research that we do. Final thing is that our clients, let's say, they are not just local communities, for example, that could be, but they are also the regional governments like Flanders, Wallonia, Brussels, the federal level, because you live in Belgium, which is a federal state. And I think half about what we do is also about European projects. This can be contract research, like some of the parts that will be presented by Tim. They are based in, they found their roots in contract research, where we work for director generals like DG. But we're also doing horizon projects, for example, or other subsidized projects in which we try to develop new models or try to figure out what would be an interesting research question to answer and how to help the community with that. Now, for the next hour, there are two speakers here in front of me. They will enlighten you with all their knowledge. You can ask questions right after them, but try to keep them very short. If it's like, is it like that, yes or no? And they would be able to say yes or no. That's a question we can have. If it would lead to a bigger debate, then I would suggest we keep it for afterwards, because there is time after the two presentations. They will last about 20, 25 minutes. After that, we can still have a discussion on whatever is in your head at this time. Also important, you may look around you and you may notice, the room is nicely filled. We can have a lot more people in here, but they're not here for the moment because a lot of people were not able to attend in physical person. We're also not streaming this session, so we're not taking questions from the cloud, let's say. But what we are doing is recording the session, and then it will be made available afterwards on our YouTube channel, so people can review it afterwards, and then they can still send you any question they would have. Now, if you have a problem with being recorded, then you have to tell us now. We're recording that part and me and them. It's not that you are personally being recorded, but we have pictures taken. If you have a problem, just notify us. Maybe I will just ask you to step outside for a second. Who knows? And on the other hand, if you also have ideas for another thing to discuss about, like after this talk, you say, well, you inspired me and now I have the idea that maybe you should also make a talk about this. Just come to us and tell us what your idea is. Another thing, if you're one of those avid social media people and you really want to talk about it on Twitter or whatever, then you can use a hashtag so that we can easily recognize it in the large feed of what is happening in the world. That said, I would like to present our first speaker, Maria Börjesson. I pronounced it correct?
Yes, perfect.
Correct. I have to talk to the first speaker will be Tim. Tim, you will just give a broad introduction first before you can throw in your really expertise about these things. Now, Tim Breemersch, he's a colleague of mine. He's a master in applied economics. He has an additional master in environmental science and technology. And he's, I can dare say, one of the more seasoned TML employees that joined our crew already back in 2007, if I'm not mistaken. So he knows his expertise. At TML, he really specialized in modeling economic evaluation, transport, environmental policies, and it takes energy efficiency and the emissions of passenger and especially freight traffic of transport into account. So this is where it will fertilize. He has been engaged in projects that deal with the impact of policy changes on the competitive position of different transport modes, which is important. He also has a specific focus on road freight transport on a macroscopic level. At a microscopic level, Tim is also involved in several social cost benefit analyses, also transport infrastructure, which is a topic that's also close to your heart, from what I can tell. And more recently, he's especially active with the analysis of freight transport. So Tim, I would invite you back on up here. Take it away.
All right. So we have a session here on essentially electrifying road freight transport, decarbonizing road freight transport. So my aim today is to provide you a bit of background. What is currently going on? What is the current policy that's governing road freight transport, and what are the technologies that are available to achieve that, to reach those goals? That's essentially the outline of my presentation. So quickly, background, the emissions, what's going on, and yeah, two more parts. First, let's dive right in. CO2 emissions at the European level. So we have total European CO2 emissions, or greenhouse gas emissions, I should say, at 3.5 billion tons in 2021. As part of global greenhouse gas emissions, it's about a tenth, 36.3. This morning it was on the news. There was an increase of 1.1%, so it's up to 36.8 for 2022. And of those 3.54 billion, there's three main sectors that produce that. It's energy, it's the industry, manufacturing, and transport. The next ones are significantly smaller. So transport is about a quarter of those 3.5 billion, at around 850 million tons for the EU 27 in 2021. What's important to note, however, is that among all these sectors, transport is the only one that's been growing since 1990. So there's a few others that have shown slight increases here and there, but road transport is essentially the only one that's been growing significantly since 2021. That shows how difficult it is to decarbonize this sector, and yeah, the lack of success there has been in reaching decarbonization in this sector. Drilling down a bit to transport emissions, there you see the emissions of the different segments of the market: railways, navigation, which includes both maritime and inland waterway transport, and aviation. You see road transport taking bulk at over 3/4 of total CO2 emissions for Europe. In terms of evolution, aviation has been growing the most, but still, even in road transport, which is the dashed red line, there's been an increase since 1990 of greenhouse gas emissions. So this is just putting more focus on the problem. And then drilling down a bit more into road transport, what we see: cars around 60%, and next up, heavy-duty trucks and buses. So that really heavy transport, which is what we're focusing on today, over a quarter of total greenhouse gas emissions from road transport. All in all, heavy road freight is about 5% of total European emissions. So that's the sector we're trying to decarbonize. You can see it may not seem like a lot, but it's an important one, especially given how difficult it is to decarbonize this. What's going on policy-wise? So the European Commission is trying to address that issue of mitigating climate change by implementing several policies, including one that was implemented in 2019 at first, a heavy-duty vehicle CO2 regulation. Essentially, vehicles are being certified using a specific tool the vehicle emission, vehicle energy consumption tool, Vecto. And so this regulation was only implemented in 2019, and actually there's already an update being proposed. The initial targets were to reduce greenhouse gas emissions by 15% by 2025 and 30% by 2030. In light of new goals, in light of energy independency, so they're already considering that revision, and it's going to be a lot more strict. So by 2030, the goal is now to reduce by 45%, up to 90% by 2040. So 15%, maybe you could say, yeah, that's still within the capabilities of working with the current engine, current technology. You can still make that a bit more efficient. Then you implement a bit of other technologies. If you want to go to 45%, if you want to 90%, it needs a radical change. So that's what's on the table right now. There's a good chance this is going to end up being close to the final rules. And this is all part of a more general attempt of the Commission, of the European institutions, to reduce CO2 as part of the Fit for 55 strategy to reduce greenhouse gas emissions by 55% by 2030, the smart and sustainable mobility strategy, and overall the goals of reaching carbon neutrality for the entire continent by 2050. How do they want to achieve this? Basic framework to achieve emission reductions: avoid, shift, improve. You may know, heard of this general framework. First of all, you want to avoid transport. You want to reduce the number of trips by loading your vehicle more efficiently, carrying more cargo on a trip. Could also do this by having bigger vehicles with higher loading limits, for example. That way you have fewer trips, fewer vehicles on the road. Shift to other modes. Modal shift is a very principle that the Commission has tried to support for the better part of the last quarter century. Shifting to rail, shifting to inland waterway transport, shifting to maritime short sea shipping, which are lower in carbon emissions, lower in external costs as a whole. And then to improve in making the vehicles that you do still need, making them better, making them less carbon intensive. This summer, the Commission launched its greening freight package in order to support those goals specifically for the freight sector. It consists of 3 packages: the Weights and Dimensions Directive, the Combined Transport Directive, and the Count Emissions EU policy. We at TML worked on the impact assessment for the new Weights and Dimensions Directive, which contains certain provisions, certain exemptions for zero emission transport to make it more manageable for transport operators to use these zero emission vehicles. Also supporting combined transport. The Combined Transport Directive itself is intended to support the rail and inland waterway sector by facilitating their use by making it less expensive, and by essentially removing all of the obstacles administratively and practically to use combined transport. And then Count Emissions EU is more of a supporting policy where companies can certify themselves, certify their emissions to increase their visibility and track their emissions better. Now, in order to achieve zero emission transport by using different technologies, all of these new energy carriers, these new fuels need to be supplied. Vehicles need to be able to use them, and there's the Alternative Fuels Infrastructure Regulation, which states that there is a minimum amount of refueling, recharging stations that need to be installed along the primary road network, which is the Trans-European network, essentially the main highways of the European Union, about 30,000 kilometers, along which there need to be enough charging stations, refueling stations for the different fuels. And then, of course, the heavy-duty vehicle CO2 regulation that I talked about earlier, also part of those emission reduction. So for the final part of this introductory presentation, I would like to run through a few of the new and sustainable energy carriers that are being considered, that are part of the mix, and give you a bit of background on what their benefits and their downsides are. So electricity, either battery electric or electric road systems, hydrogen, fuel cell or internal combustion, biofuels, and then synthetic e-fuels. Start off with battery electric vehicles. The pictures you see at the top on the right is the Tesla Semi, transporting what I think are potato chips, a very important resource for the economy, of course. And then on the left, you see the Daimler Actros, which was recently launched. The Semi has a range of around 800 kilometers. The Actros has a range of around 500 kilometers, I believe. What's the advantages of these battery electric vehicles? One, they're efficient. Electric engines are a lot more efficient than internal combustion engines. 70 to 80% of the primary available energy is transferred to the wheels. They're quiet, electric motors. There's very few moving parts. These engines are very quiet, which helps both the environment and the driver. There's no tailpipe emissions. There's no fuel being combusted, so there's nothing coming out of the vehicle. And this is it's a relatively young technology. It's still improving. So there are vehicles on the market. There's still quite a lot of potential to be had in improving the vehicles. What are the downsides? These vehicles are heavy. Well, specifically the batteries are heavy. At this moment, they're heavy if they want to achieve the same operational profile as current diesel vehicles. These vehicles, if you want to drive them for a full day, that's around 800 kilometers that you need to be able to drive. In order to achieve that, you need a battery that's around 1,000 kilowatt hours. Such a battery at current energy densities will weigh around 5.5 tons. That cuts into payloads. That has an impact on the infrastructure, creates more road damage. So that's a difficult position these vehicles are in. Because they're so heavy, that limits the energy storage capacity. You can have smaller batteries, but then you can drive shorter distances. They're relatively slow charging in the sense that you can't just fill such a vehicle up in 10 minutes or 15 minutes and get back on the road. No, it takes an hour or several hours, depending on the speed of the charging, to recharge the batteries. And they're very expensive for the owner, at least in terms of the purchase cost. Battery electric truck can cost 3 to 5 times as much as a standard diesel vehicle. Standard diesel vehicle, you have to count on maybe 125,000 euros. This one can be 300, 400, 500,000 euros in purchase cost. You do make some of that back as operational costs are lower, energy costs are lower, maintenance costs are lower. So there is still there's a way to pay it back, but the financing models at least will need to change. Next, you have electric road systems, and there I'm already moving towards the next presentation a bit. Essentially, they have a lot of the same upsides as battery electric vehicles, in the sense that they're efficient, they're quiet, they just get their energy from the overhead power lines or from the road. There's two systems. On the left, you see one with a pantograph that needs to be installed on the vehicle. Costs about 25,000 euros to install such a system, and then it takes the energy from those power lines and moves them directly to the vehicle itself. That means, if they're combined with a battery electric vehicle, the battery can be a lot smaller. You don't need as much. It doesn't cut into the payload as much. and it's a lot less expensive to buy such a vehicle. You can also combine it with diesel vehicles. These vehicles are actually actively being tested combined with diesel propulsion systems. So they are multi-compatible, as you would say. What are the downsides? Yeah, of course, this needs to be installed on the road. Such a system with overhead lines costs around 1.7 to 2 million per kilometer to install on a highway. So that's expensive. Those costs need to be recovered in order to make the system economically viable. This is still these systems are being tested. There are trajectories in Germany, in Sweden, where they are actively being tested, but the reliability in all kinds of different weather circumstances, that's not yet proven. That's a work in progress, I would say. Doesn't mean that it's necessarily a problem, but it still needs to be tested. And of course, the fact that you do still need these vehicles to be equipped with other propulsion systems, because you're not driving on a road with overhead cables the entire time. It does need either a battery to drive its electromotor or a diesel vehicle to, for the last mile, or to overtake, or in case a part of the charging network is not available. Next, we go to hydrogen fuel cell. It's essentially an electromotor powered by electric energy stored in hydrogen rather than in a battery. So it's quiet, has no tailpipe emissions, and has a benefit because of the much higher energy storage capacity of hydrogen, has a much longer range than battery electric vehicles. Downsides, it's expensive. It's not expensive as a battery electric vehicle, but still it costs quite a bit. The main downside is its energy inefficiency, I would say. As I said, a battery electric truck converts about 70% of its primary energy to power on the wheels. For hydrogen, it's closer to 30, around 30%. That's worse than an internal combustion engine, simply because there's so much energy conversions going on. The primary energy needs to be converted to hydrogen, then converted back to electricity in the fuel cell, and only then can it start being used. So those are very inefficient processes that waste a lot of energy, and that essentially you need 3 times as much electric energy and electric generation capacity, so to power these vehicles if you would only use them. So if one windmill is enough for a certain amount of trucks, you need three windmills to power the same amount of hydrogen vehicles. Another downside is the storage of hydrogen. You can see on the picture, the front of the cabin, that's where the driver sits, but all of that behind him, that's storage for hydrogen. So that takes a lot of space. That also cuts into payload. So it's not just weight. In this case, you're actually cutting into the volume of the amount of cargo you can carry. And then in addition to that, the safety. So hydrogen storage and transport, there's still issues with safety being worked out there. That hydrogen is a very flammable gas at ambient temperature, I would say. So there are some risks that still need to be worked out before this can be rolled out commercially at a large scale. And then, the supply of green hydrogen. There's hydrogen can be supplied, but it's mostly done using fossil fuel as a starting point. Having green hydrogen using green electricity, that's the capacity there is still very, very limited, and it remains to be seen whether there can be sufficient green hydrogen made available for an energy intensive sector such as freight transport. Moving on to biofuels. Hydrogenated vegetable oil, biological natural gas, for example. These are essentially already available. So you do have vehicles using these fuels already. They can essentially be using the same vehicles that we have today, with certain adaptations maybe for older vehicles, but essentially this doesn't change anything. So you can use the same vehicles and you can use the same refueling infrastructure. Downsides, well, the greenhouse gas reduction potential tends to vary, I would say. Past biofuels had, in some cases, didn't reduce greenhouse gas emissions at all, considering the entire life cycle. These days, most modern biofuels do achieve greenhouse gas reductions 50%, some even claim 90%. So there is some reduction, but you never get to net zero with these. They're more expensive to make. That's an important one. Again, as with hydrogen, is there enough organic material available to make these sustainable biofuels? And since you're still using combustion technology, you're still getting tailpipe emissions. So this is still producing NOx, this could still produce particulate matter, and that's not an issue you're solving with these. And then e-fuels wasn't able to find a decent picture simply because they're still so very immature in terms of technological advance. What e-fuels are, essentially, they're synthetically recreating the fossil fuel we're using today in a more pure form, completely carbon neutral. So if you use clean electricity and you use clean electricity to generate hydrogen, you take CO2 that you capture from the air, and then using additional electricity, you can make a completely carbon neutral fuel. That's the ideal situation, I would say. Again, this is you're using the same vehicle technology, using the same refueling infrastructure. Problem is, this is very expensive. What they're projecting right now is that e-fuels would cost 2 to 3 times as much as classic fossil diesel. So that's going to cut in the bottom line of transport operators. It's a very young technology, so there are factories that produce e-fuels. They're still very limited in scope, and their production capacity is still very low. And the same downsides as biofuels, you're still using inefficient combustion with 40% thermal efficiency, and you still get all the same tailpipe emissions that you get with the diesel vehicles that you're using right now. That's the overview. That's what current technologies are to reduce carbon emissions, considering the prospects of the European Commission. So with that, I would like to conclude. Road transport is the largest European sector in which CO2 emissions are still increasing. So there's a great pressure to start getting those emissions down. Heavy freight demands high performance. So these are vehicles that are on the road a lot. They drive all the time. So you do need high performance vehicles in order to have an economically viable transport sector. There's several reduction technologies that exist that I presented, but they are at various stages of development. So it remains to be seen which of these will be economically relevant by when. What the Commission is counting on right now are those fuel cell electric vehicles, battery electric vehicles, and e-fuels. So some of these have serious downsides. And there's actually no clear solution yet. There's no way of telling right now what the optimal solution is going to be. Still a lot of technological development going on. So we're still a bit of in a wait and see situation, depending on those innovations. Considering also that it's becoming very urgent to take action and to actually get things going in line of meeting the carbon emission goals. Yeah, no clear solution yet. But maybe we're going to hear about a good solution.
A clear solution.
A clear solution in the next presentation.
With that, thank you for your presentation. It was very clear overview that helps to set the stage. Now your stage is on.
Yes,
and,
I'm very grateful.
Thank you. So Maria, she's a Swedish civil engineer in technical physics, also professor of economics with a focus on transport at the Norwegian Road and Transport Research Institute. You're also affiliated professor at the Royal Institute of Technology in Stockholm.
Not anymore.
Not anymore.
Sorry, it's Linköping University now.
I will now have to say that we will need to update the Wikipedia page of our guest. Now, in any case, as a researcher, you contribute to understand how society can balance the various aspects such as prosperity, trade, the distributed effects of scarce resources, which is the basic of economical theory, climate accidents, and other undesired effects of transport, for example, external costs, etc. Now, as an academic, you have written definitely several and more than several articles on infrastructure and the cost effectiveness. Some about the rail transport, I remember, in Norway, and the congestion tax in Stockholm and Göteborg, which is also interesting to talk about. But let's keep that for another day. So, with that, I would give you the floor.
All right.
I also noticed, Tim, you wanted to point at times.
Perfect. Perfect for you now. So I'll point all the.
This middle button.
Okay, perfect.
Have fun.
So first of all, I'd just like to say thank you for inviting me and for this very interesting session and for this very accurate summary by Tim for what how big this problem is and what we can do about it. So in this presentation, me and Steph sitting over there, we're trying to actually put prices and costs to do all your advantages and disadvantages that you you had, and trying to figure out what would be the optimal solution. And you can say, why do we need to know that now? Well, if we're going to invest, or if European countries are going to invest in these electric roads, or for that matter in charging points, or whatever solution that is made, we need to do it now because this takes time. So that's why we need to do these things now. All right, so I start where you ended with all these things. You start with modal shift, or the problem is that mode in freight transport is almost always determined by the distance, the value of the cargo, and the value of time. And that is very stable. And what will happen over time is that the high value cargo is increasing. So we keep creating more valuable stuff. And that means that road transport is actually increasing, because that's where you can have your just in time, your high value cargo. So even if both the Swedish government and I assume also the Belgian government and the EU government is trying to push for more railway and more maritime transport, the truck transports keep growing. So that's why we started. And you can do like loading factors. And actually in Sweden, we allow 60-ton trucks, which I don't think is allowed in the rest of Europe. So that could be something, but I know it's only Finland and Sweden. So maybe that could be something, but in Sweden we cannot do that because we already have these high heavyweight trucks of 60 tons. And I think they're not allowed here because of
Trials, they're using trials.
Oh, they're using trials, okay. Okay, as you say, limited to sustainable biofuels. So basically what we came to the conclusion, the only things left is that we need to electrify this road transport. There's nothing really we can do. And this is basically what you said, Tim, so I don't have to repeat it. This is also what the European Union says. All right. And then you were discussing hydrogen, and you were also discussing why this may be that like you lose a lot of energy. I would also like to add to this that you also need then double supply systems. So this infrastructure you need to supply the electricity or the hydrogen to the road. If you need two systems, it's going to be twice as expensive. So personally, even if the EU Commission in this baseline report believe it, Steph and I don't really believe in this hydrogen thing. At least not for trucks. It could be used for many other things. So we probably see it in other markets. So that remains the remaining two technologies that we have that we get rid of now is battery-only trucks or these electric roads. So what would be the best option for the EU? So our research questions in this research paper, as it's still work in progress, but we have some results. So it said welfare improving for the EU, saying that now the EU is one country that we could do this coordinated to invest in these e-roads, or should we go for battery electric vehicles for these heavy trucks? If we think that this is a good idea, should we do it now? where we can electrify transport earlier, or wait when we know more about the cost, and obviously the cost will decline as well. And also mean we might know more about the cost of the e-road. We might also know more about the cost and the weight of the batteries if we wait. So should we do it now or later? How should we deal with this problem of network effects? So if one country in the EU decides to go for e-roads, this will also affect another country in the EU because we have a lot of international traffic. So if this is not determined on the EU level, but down to the countries, the member states, which is actually the fact, how can this be coordinated, and can this work out as a coordinated solution? And can we fix this coordination? If there are countries like Sweden, for instance, which is not that heavily populated, long distances, and a lot of international traffic, can we get Sweden to agree on this anyway? For some reason, Sweden already invests a lot in these things, but maybe we shouldn't. Right, so that's the questions. Basically, I don't really have to say this because Tim was already saying this, but I just a short repetition here. So the good thing with the battery trucks is that they have batteries, big batteries. So the days when they don't make these long trips, they can actually be used for vehicle to grid. So they can supply the network with the electricity in daytime when electricity is more expensive, and charge during the night. And you also don't have these coordination issues. So they are sort of self-sustaining. But then, as Tim was saying, they have this large battery, which takes up part of the load capacity, the payload capacity. And it does, if it has to charge en route, that will take time. It will also be very costly too, because they need contracts with these charging points. Also making sure that it's very expensive for these firms to have drivers standing there waiting in the middle of the day, not driving. So that's going to be a large cost. Whereas the battery, like the e-road trucks, the bot trucks, they're smaller batteries, so not that heavy, not that costly. And also they don't need restricted charging stops. But the problem is that this is going to be a large cost for the governments in investments, and how large we can discuss its uncertainty. And then we have the big uncertainty these governments face now is that we don't know what the battery cost will be in the future. We don't know what the battery weight or density will be in the future. There are predictions, but we don't really know. We also don't know what the investment cost of the electric road will be, and we don't know what it will cost to maintain, particularly not in Scandinavia or like Northern Europe where you have but heavy winters. So we set up this model, and now we think about the TNT network in Europe. So we think it's realistic if it was electrified, that this is the network that would be electrified. And we have period one, say from now to 2035. That's like if we're going to do it now, and then we assume we know the costs. Or we can say we do it in 2035, which would be period two. And in the period two, we are not sure about the cost of investment, and we're not sure about the battery costs and weight. So that's the setup. All right, so then we assume here that we have long trips and short trips. And the EU legislation says that one driver cannot have a longer drive than 9 hours per day. So we assume that the long trips are 9 hours. And then they also say these legislations that a driver can drive maximum 4.5 hours before that driver needs to take a rest, at least 30 minutes. So we say we have short trips, and they are 4.5 hours, and during that time we say the battery can last, and also there is not going to be any break because the driver can just drive. And then we say we have each and every truck has a value X, and that is the share of days in a year that this truck makes a long distance trip. So we say every day the trucks make a trip, and X share of days during a year is long trips, and 1 minus X share of the days are making short trips. So we have some trucks making a lot of long trips and some trucks making a lot of short trips, which is going to impact how the cost of the battery, how it pays off. So then we have this is the average yearly distance of the truck. So the trip length of the short trips, the share of days making short trips, and the trip length of the long trips, and the share of days it makes long trips. Then we have this battery, and we're going to optimize the battery size to determine what will be the optimal battery size for these trucks. And then we also say that we always need a 20% margin to take care of battery. So we shouldn't be completely done of energy. And then we set up a cost function, which is sort of the daily average cost for each truck, the BAT truck and the BOT truck. And we're taking into account the capital cost that you were saying it's more expensive, particularly for the battery truck, if you have a large battery. So that's going to be more costly. And we also take into account that the days when this truck is not making long trips, it can use the battery for charging the network with vehicle to grid. So you can actually gain some money from having a battery if for the days you're making short trips. And then we optimize the battery size to see what would be the optimal battery size, depending on whether the trucks make long trips or short trips. And also take into account that they need to stop and charge if they have a smaller battery and making a lot of long trips. And then we just calculate the total cost for the trucks and see what would be the cheapest option. Now you can guess what you think will be the cheapest option.
Do it now.
What?
Do it now.
Do it now. Do electric roads now.
Yeah.
Are you all right? Why?
Just guess because currently we have the cost and we know the cost
Yeah, all right.
and we know also we have some idea about the distances.
All right. Yeah, we do.
And
All right. Anyone who wants to have a different opinion, or we all go for invest in electric roads then? Okay, we'll see. All right. So we just have. This is a key thing. So the electricity price of the electricity will vary depending on where you charge and also from who. So it's always cheapest, we say, to charge home at night. So that's one electricity price. And then if you can sell electricity to the grid, you're going to charge a higher price because then you can do it at the moment when the capacity or there are less electricity on the market for that hour. So that's going to be higher. Then it's going to be even higher to charge while you're driving. Because as I said, then these firms need to sign up contracts with charging points so that they know that they are not having drivers stuck waiting for capacity. And that's going to be costly. And then we have this electricity price when you're charging from the overhead lines. And then there is several authors who made this assumption that the government is going to pay the investment, but they're going to charge 2 to 4% of the investment cost. And that, they say, is going to be equal to the maintenance cost of these roads. And if we go for that assumption, we have a pretty low price of electricity when you're charging from the overhead lines. But it's also true that it's going to be a lot smaller, this price, if you do this in a densely populated network, like Germany, for instance, where you have a lot of trucks that can share this maintenance cost, compared to, for instance, Sweden, where you have much fewer trucks. And there are fewer trucks that can share this cost. So it's going to be higher electricity prices charging from these overhead lines in Sweden, for instance, and in Germany. Then you have the weight of the battery. Then we also assume that the battery must be of the battery truck would be at least as large. So to manage the short trips, so 4.5 hours, we assume. So there's not going to be stops during those 4.5 hours. And it's not going to be larger than the 9-hour drive. So at least, it's going to use the full battery size when it's making these long 9 trips. Okay, so these are the equations. So this is the daily cost. And I will not go into these because it's a horrible equations when you're sitting in a nice lounge lecture like this. I'm just going to point out a few things. First of all, this is the daily cost of the overhead line, the BOT truck. And this cost crucially will depend on the share of the network that is electrified, which is in this equation is theta. So if you have a large network and if you're in international trips, it's going to be important that the other country is also having the electric road. Otherwise, this theta will be small because you cannot use the electric road in that other country. So that's going to play a big role. And this is the cost of the BOT truck. And what's important here is that it will depend on the price of the vehicle to grid. So what you can charge when you're not using your battery yourself, but you can sell the electricity. And it will also depend on the size of the battery that's relative to the trip length. So if you have a smaller battery, it means that you will have to stop charge, and that will be a costly time cost for the driver, has to stand still and wait while the truck is charging. And it's also going to be more expensive to charge because the electricity price on public charging F0 will be larger. So this is kind of, and then we just have this old fashioned diesel. All right, I think this is the results. And this is first the optimal battery size. So we see in the later period, when the batteries are cheaper, they will all go for the large battery, the battery trucks. Whereas the overhead line trucks will always go for smaller batteries. This is basically what they need just to cover the distance that is not covered by the network, the overhead line network. But you see in the first period, it's only trucks making mostly long trips that will have large batteries, while the trucks making a lot of short trips will have much smaller batteries. So they will have smaller battery, even though they can use the battery for vehicle to grid. And this is the cost. And here on the x-axis is the share of trips, share of days the truck is making long trips. And that's the daily average cost of the truck, including all things. So what we see is that you were right. So the butt truck here is going to be cheapest, even for short trips and for a lot of long trips. And the diesel truck is going to be costly, the worst, and the battery truck will be in the middle. So this, now we haven't though included the cost for the government here, but this is just for the users. It seems that they will go here. And the battery truck, even if they can use, so this is smaller for a lot of short trips, because they can have smaller batteries, but also they can use a little bit more vehicle to grid for the days they don't make long trips. Here.
Diesel is already so expensive because?
Yeah, because of the fuel.
Fuel price.
The fuel price. Because long distance trucks, as opposed, for instance, for cars or heavy trucks, they use a lot of fuel. So this is basically why the diesel is expensive.
And this is already taking into account that the infrastructure has been built, or?
Yes, so here we assume that the infrastructure is being built.
It's already built.
Yes, and maybe this is why we don't see so many battery or trucks yet. It's maybe unreliable, but also they don't know for sure where to charge. So it's, yeah. So this is actually essentially good news. Yes.
Is this around for Sweden or European? Because, for example,
Yeah.
electricity prices in Belgium, I think, are 3 times higher than in Sweden.
Yeah,
And I think there will be also a bigger variability during the day
good
than in
point.
Sweden. So I think you will have completely different.
Very, very good point, and I think so. But I think I hear now the nuclear power plants in Sweden have trouble. So now I think we have Belgian prices, but these prices, all prices are taken for EU average from the ECCT and PR. So it's not Swedish value. So you go for sort of in taxes and prices, and they can vary, but this is the best we could from EU averages. And this is the result of the period 2. And in this period 2, as I said, we have 2 scenarios. One scenario when you have cheaper batteries, when they are lighter batteries, and also when the cost of the E-road is investment and maintenance cost is higher. That's one scenario. And then we have the opposite scenario when the electricity or where the battery size and weight is higher and the maintenance investment cost of the E-road is lower. So that would be the 2 extreme. And here you see still that in these green and like you see. No. How do I?
The second one.
That's what I was afraid of. I did this before. All right. So you see this is the bot truck here, and you see it doesn't really matter the daily cost, whether the battery cost is high or low, because the batteries are so small. But it's still more, in both scenarios, more lower cost than in these battery only trucks. Here the blue and the yellow line, and they are a little bit further apart because the battery cost will play a bigger role for these box trucks. So even in both scenarios, it's cheaper for the truck companies to have these electric road trucks in both cases. And in all cases, the diesel also in period 2 is more expensive. So even if the battery development is slow, and here we have sort of taken really, really slow. We have the scenarios by McKinsey and PIAC and all these assessments. It seems like it's going to be more expensive to have the diesel truck in period 2, which is good news. All right, so then here is a simple cost benefit analysis of building the E-road in the first period and in the second period. And here's one scenario when you have a high cost of electric road, low cost of electric road, high cost of electric road. Here you see that in all scenarios, it's positive net benefit cost ratio. So here we've taken the daily cost, we've made a discount for every day over the year. We assume that the E-road can work for 10 years, 4% discount rate, marginal cost of public funds if we use public money to invest in this E-road. So all the details are basically in the paper, so I'm not going through them here. But here you see that even if you take into account this large cost for the governments, it's going to be positive net cost benefit ratio, both in period 1 and period 2. Even if you end up in a scenario when it's cheap with batteries and costly with electric roads. So you were right. I was surprised. I thought it was a bad idea, but I was wrong. All right. I don't have so much time left, do I?
No.
All right, that's what I thought. Okay, so I'm not going to say a lot about this, but we only, so I make a very short story, long story short. So say now that we've treated the European Union as one country. And that we have, so that they share all the roads when they have high, or all the roads in the TNT system where there's high volume of traffic and low volume of traffic. But let's say now that this is actually down to member states. And then we've taken what we think two pretty extreme cases. We have Germany, which is high density and quite low share of international traffic because they are like a big country. And then we've taken Sweden, we have low volume of long distances, low volume per road kilometers of heavy trucks, and also a very high share of international traffic because we're a small country trading a lot. And then what we will find is that this is not going to be welfare increasing for Germany. Oh, electric road is going to make sense for Germany, yes, but it's not going to make sense for Sweden. So it's going to be negative for Sweden. The net cost benefit ratio, here you see Sweden, Germany. So then we ask the question, so would Germany benefit from Sweden investing in this road? Because if Germany would benefit from Sweden investing in it, then maybe Germany could subsidize Sweden. And then we find out that this is probably not going to, Sweden's not going to benefit from this either, because it's just doesn't make any sense for Sweden. So this is the way how you can deal with corporations when you have these networks effect. So we are not going into details here, but just to skip that and go to the conclusions, and we can discuss this in the discussion later. But what we find is that EU, yes, they can be welfare increasing, particularly if you see EU as a country and you coordinate it from the EU Commission, basically. And it's also going to be a welfare increase in countries when you have a high share or low share of international traffic and you have a high density like Germany. Probably going to be a good idea. And even if this vehicle to grid helps the battery only electric truck to increase its cost a little bit, it's not going to be able to compete with this E-road. But what this last analysis shows also, that this is probably not going to be good everywhere in Europe. So in countries like in Scandinavia, in Sweden, probably Finland, and maybe more remote parts of the European Union, maybe it's better to them have battery only trucks that are more flexible and then they can run on batteries. So I almost made it in 20 minutes. Okay, I'm done. Thanks.
Thank you. So thank you. That was interesting, and I can imagine already some questions in my head, but maybe I think some people among you are dying to ask some questions, so floor is yours.
Actually, I didn't understand what cost, how did you consider the cost for infrastructures?
Yeah.
For the e-roads, so how did you calculate that?
All right, so we assume that the government pays the e-road with public funds. And we assume that the maintenance cost is covered by user charges on the e-road.
So then there is no additional, let's say, cost for e-roads because you assume that they are already somehow provided, right?
No, we assume that the government has to pay for it.
Oh, okay.
Yeah,
But guys, the user pays the fee, including infrastructure costs.
they only, the fee that the users pay only include the maintenance cost. Yeah, that which is, so this is at an early stage, but we don't know what the marginal cost of using the e-road is. So we can guess, but what most other studies have done is to assume that there's a fixed maintenance cost and that this can be covered by the users, which means then, and maybe that is relevant or probable. But so what the effect of this is, it's going to be cheaper to use the e-road in dense countries than in less dense countries, yeah. But obviously you can change these things when you know how more data and they only cover the marginal cost or something. Yeah, if you knew the marginal cost, that would be good. Yeah.
Okay.
So it's just a question of clarification. So such a box truck or overhead line, it still has a battery? So
It still has battery.
Still drive like, let's say, 200 kilometers?
Yes.
Yeah. So you still have that cost?
Yeah.
too.
Yeah, right. So that battery, the optimal battery size for that truck is about half the size of the truck making short trips. That is a battery only truck.
Stop.
Just two things. The first one is on the payments, maybe, of this electric truck. Well, there are a lot of European countries that have kilometer charging or road charging systems.
Yeah.
So it could be integrated. That's one thing I see. The next is that I've been working on the extension of kilometer charging system, and then also the electrification. And there we see really strong change, a strong preference after 2030 for electric trucks, really the full electric trucks, because they project a very, very big decrease in cost. Actually, if you look at the PCOs, it's already getting more or less good after 2028.
With the battery only electric truck.
The battery only electric
Yeah.
trucks. And so maybe then if this is true, because of course we don't know. So for example, to model a development which is more conservative, I have to use a preference, a negative preference inside the discrete choice, a very big negative preference for electric trucks, because otherwise the market is kind of overrun.
Yes. And that is actually what we get also, you know, so the cost of the diesel truck is always highest. But if you go to the truck companies, we have truck manufacturers in Sweden and say, so why don't we only use battery truck now? And they say the problem is the charging infrastructure. And it's one thing is the charging points, that they need to be very, very reliable, but also they are afraid that they don't have enough power during night hours, for instance, because of the cable, the distribution system. When you have all these trucks charging at night, you're going to need a lot of power at these points. So that's what they think. And then they're also a little bit skeptical, I would say, at least like Volvo Scania for this electric road, because they don't trust in the government can put this up and make it reliable.
Okay, so I did the research on electric trains, electric battery trains. And then one of the things that I thought before I did this project is that you needed to have, like, let's say that the train had to like stand still and then you had to charge it. Actually, that's the least efficient mode. It has something to do with the technical issue that you can actually get more amperes when you're driving. So maybe that's how you can sell this also as a kind of, let's say, mobile recharging points for trucks. So maybe you don't need to electrify the entire network then, but if the same is true as for electric trains, maybe you can have very efficiently charging at some points in your network, and that can actually strengthen this whole story about recharging trucks.
Could be.
So, and I think that maybe the extension of like putting this kind of thing that can then go to the cable is not that big of a deal anymore. So it's just a kind of, let's say, parts of the network, and then you can electrify the whole thing much more easily.
Yes, but the one thing will still remain, like we need the power to the road somehow. And it's going to be a lot of power.
Yeah.
Yes.
The cables,
Yeah,
I think it's a weak link.
you need a very high voltage. to get
Exactly.
Enough charging capacity.
Mm.
Of course. That will be the problem. But some of the motorways are already close to rail tracks. So if you could buy some in some areas. where
But
they-
that wouldn't help because the power of the rail, it's not a little power. They need a lot of power. So this means these cables are not enough.
You cannot use the same technology as.
We just need more cables, I think. Either way, for all these technologies, we need these cables.
Basically, because, yeah,
Mm.
that's what you-
For battery only trucks, like making normal trips, you assume that they would have to charge
Yes,
while driving actually, or
they have to stop.
to charge?
Mm.
How long did you assume that they have to charge? And did you also take into account the time that they anyway had to wait? Like, that's not really time that can be taken into account as cost for time to charge.
Yeah,
They anyway have to rest actually.
very good point. Yes, so that would reduce the cost that they had to stop anyway. But maybe they have to stop longer because they have to deal with this. And we try to take that into account, yes. And the amount of time they have to stop has to do with the size of the battery. So that's included in the optimization of the battery. So if you have a large battery, you only have to make a short stop. If you have a very small battery, you have to charge, fill up the whole battery, and then it's going to be more costly. They have to wait longer. So it's sort of internalized in the model. Which is why in the later period, they all have big batteries because it's so costly to stop and charge. You have to pay the driver and so on.
Yeah, I have two questions. One, what is several figures you showed the share of long distance on the x-axis. What is the share of long distance driving that?
Whoa,
Like,
yes. I don't have it. I have, there it's in a paper. I'm trying to reach, to have all the figures that is accessible for truck traffic on the TNT network. And then there are some sources actually of distances on the TNT network. Okay, a lot of trucks make a lot of short trips, making 4.5 hours.
Mhm.
And there are some long distance trips. So we're trying to take those figures as accurately as possible from reality, the way it's measured. But there might be errors, but I think it's fairly robust, these results to these shares of trips. Also, you need figures for the number of trucks we have in the EU and so on, which is a little bit tricky, but we only did our best.
And there are, in the European emissions calculation tool, there are different driving profiles.
Mm.
One is long haul, one is medium haul. Long haul is typically anything above 400 kilometers. So that's what they call long haul.
Yeah,
It's not necessarily a long trip,
Yeah.
as you would say in
That is
your
it.
model.
Exactly.
And those are, if I recall correctly, represent around 30 to 40% of total energy consumption. So not necessarily driving a number of trips, but energy consumption. So that gives you an idea, not very accurate and of course very rudimentary, but it's
They cannot.
the data is difficult
Yeah.
to get.
But I think it's fairly robust.
Mhm.
Because it's also the bot truck is more, is cheaper for all axes. So I don't think it's so sensitive.
Okay. And the other question is maybe not really yet good in my mind, but I'll try and explain it. So at the beginning, we sort of ruled out from the study modal shift to rail because we said, road transport is becoming more and more, I guess, economic as well for high value goods. Yeah, traffic is a huge problem, especially in countries like Belgium and also Italy, where I come from. And then there's countries who, like Switzerland, I think, also makes mandatory, I think, no, some trucks to actually go on rail. So I was a bit, I wish I could see also the rail part and how much of this could be on rail and what would be the actual cost difference. So yeah, do you have any further elaboration on that?
Very good comment. Well, the thing with the rail also is that you need fairly long distances because you need a lot of reloading with rail traffic. So I think it's going to be difficult to get this cost efficient. But I also think even if we could manage to have some more rail traffic, the amount of reduction that we need to do in carbon emissions that you were saying is huge. So there's only, and the largest emissions are in the road sector. So we need to try to deal with that. Even if we can shift maybe a few percent, it's going to be difficult. To rail traffic, we still need to do something with road traffic. But I think we've tried, the European Union and many, it's trying to shift more to rail, but it's difficult for these reasons.
It is actually happening. I mean, more and more traffic is being shifted to rail, but the growth of total transport demand is actually higher than what can be shifted to rail. Rail has its own issues, of course. It has infrastructure issues, it has coordination issues as well. So rail traffic is growing, but the share isn't necessarily growing. It's really more or less constant.
The share is actually declining if you look at Eurostat. Yeah, I did it yesterday. The share of rail transport is declining in the EU and in Sweden, because also the economy grows, so the total transport volume grows. So we're trading
absolute figures, absolute volumes of rail are increasing.
Yeah,
Just more slowly.
road is increasing much faster than rail, but also road infrastructure is increasing much faster. Yeah, a lot more than rail is almost constant in the last 30 years. So I'm wondering how far.
But that's one other, because I had this shift to rail project, and then I looked into the statistics, and you can see that European countries that have expanded their rail, so this kilometers of tracks, they are not the one increasing rail most. So I don't think so much about increasing the infrastructure. It's much more about using the infrastructure wisely. And it also depends a lot on where you have this infrastructure. And I think obviously for countries like Belgium, you need road pricing, obviously. So you need for these trucks and these traffic to pay the full marginal cost. So I think that would be the wisest thing to do.
We have road pricing for trucks.
Yeah. Maybe it's not enough in the cities, or if they still.
Not yet covering all extent.
But
No.
I think you made another road pricing sense. In just road pricing, it's a kilometer charging that we have. We don't have road pricing in function of the time. And the congestion. That's.
And the accidents, exactly. That's what you need. If they're causing problems like in terms of congestion and air pollutions and so on, they should charge for that. And it matters where they drive also.
It's a kilometer charge and it covers infrastructure costs and emissions.
Yeah. So I think that would be the best thing to do.
You other questions too?
Yeah, a minute ago, we were talking about resting times and charging times as well. And I was just wondering, within your model, how did you work around the evolution of charging stations? Because in a year or 2, 3, maybe 4, there are going to be megawatt charging stations. So the charging times are going to go down in the near future.
Yeah.
How did you work around that in your model?
Yeah, very good point. So we used the cost from ICCT report, and this is also for the reasons that you're saying now. It's more expensive to charge en route in the first period when you have fewer charging stations and maybe longer queuing times and less efficiency than you have in a later period when we believe it's more charging stations. So the cost declines a little bit, which is also why the battery-only truck also becomes less costly in the later period. So we only use the assessment from that report for the TML network. Yeah. But these are all unreliable stuff looking into the future, yeah.
Any other questions?
Are you good? Oh, sorry.
Sorry, I parsed in a bit late. I had the wrong time in my agenda. So I started too. So maybe you covered already my question, but I'm working most in the middle mile and in the last mile. I was very happy to see the rise of trucks like companies like Volta and Arrival. But then, yeah, a few years ago, but then now see all those companies going bankrupt or in bad papers. What's your take on that? Because a lot of companies were looking into those kind of technology investments in order to electrify the fleet. Do you have any?
You mean in the last mile? So can you explain a little bit more?
Yeah, the last mile and the middle mile
Yeah,
of transportation. So from a urban distribution center up until the point of delivery,
yeah.
and then from like national distribution center up until urban distribution centers.
So they are going bankrupt?
You know Volta trucks from, I think it's a Swedish company?
Yes, are they? Yeah.
Yeah, they're
Uh-huh.
bankrupt. Mainly because their battery supplier is going bankrupt, and you see the same thing going on
Ah.
with Arrival trucks.
Actually, I didn't know that.
They were supporting to basically last mile technologies also because of the battery development. And
So
it's
I
kind of worrying because I noticed a lot of opportunity, optimism, sorry, a few years ago around that type of technology, and investments were going quite heavily into that area. Now companies are getting more reluctant and saying like, hey, but if those type of companies are not.
Could that have something to do with the higher upfront investments that there are for these zero emission trucks? Cost a lot more, and that they can't get there are no proper financing methods available to make sure that they can recover some of that high initial investment cost throughout the vehicle's lifetime. So they need more financing in order to purchase these vehicles, and that's why the market demand for them could be lower. Whereas if they would be able to get loans or some kind of government supported purchase, they would be able to have a similar TCO profile as they would with with the diesel trucks.
And the thing I was worried about is that they, from the company point of view, were looking into this kind of investments in the electric trucks, but because of this tendency, they're getting more and more afraid of the investment times. So they say like, okay, apparently the market is not yet ready, which is kind of contradictory with what we are.
But maybe it has to do with the short distances, because the reason why these electric trucks are actually cheaper than the diesel truck in this long distance market is that they drive so much, and they are cheaper regarding the fuel. So it's lost, maybe it is just the driving distance per day is too short, so they can't cancel out this higher investment cost of the truck and the battery.
Mm-hmm.
That would be my guess.
Okay. The other question I had regarding to the same topic was, do you see more and more shared investments coming up? Like at the time, Rolls-Royce made this type of, they did not sell an engine for an airplane anymore, but they needed it. You see Scania also developing this type of business models. What's your take on that? Will we see more of those?
Well, that is difficult. But I don't know. This is hard to get. It also depends on, so these vehicle manufacturers, they also have to try and guess what the government will be the response from the government. Will they make sure that they build charging stations, or will they invest in electric roads? And it's not, and where will the electric roads be? And they are trying to adapt. So I think they can change also very quickly if the government's changing.
But the framework is important.
The framework is very important, and the charging opportunities, that's what they all depend on.
What is, among your view, the tension between the targets that the Commission is imposing versus what the OEMs thinking they are capable of? Or how do you see that field evolving? Because they can just say, okay, by 2050, zero, but you have to get there somehow. Is that in alignment, these two parties, or?
Do you want to start?
I'm not sure if the Commission doesn't know. They have carbon or technology neutrality in their head as a principle. they are reluctant to make a choice. And I'm not sure if that's beneficial for the sector, because someone needs to take a lead there. The investment is very large, as you said, and I'm not sure if it can be done without making a choice, even if it may not be the optimal choice from a societal point of view. It could still be better to have a suboptimal choice that is the only choice, or a limited, the preferential choice, rather than having multiple choices where all of the investments are spread and all of the uncertainty remains. Actually, leaving this up to the market, this could be too big to leave it up to the market.
But that means that this needs to be translated to the member states who have to do the investment, so they have to also do the agreement.
Yeah,
I think, and that's probably what is the problem, because Sweden was the chair of the European Commission the first half year, and then they invited a lot of ministers and of course experts to this electric road seminar. And it's very clear that this is also lobbyists. So like now we want to build electric road, and then there are others want to do hydrogen, and others want to do battery, and this is politics.
Everyone fights for his own.
Yeah, and they sort of say yes to everything because they are politicians.
Keep your friends, yeah, okay. The room for one final question. If not, then let's thank the speakers. Then I invite you all in February next year. We will have another TML talk, which is going to be a very interesting one, because then we will talk about Traffic Scout, which is an in-house developed traffic flow model that will allow you to predict what would happen if we close down a street or change the speed limit or redistribute traffic. All these things can now be calculated for local cities, and we will give a detailed explanation of this. So thank you all for coming, and we'll see you in a couple of months.